Hello and welcome back. Today I'm gonna restore a handheld oscilloscope from the brand Siglent. It is the SHS800 series. It's handheld, it's I think sort of used for automotive because it is a multimeter and an oscilloscope in one. Just like you can find from one like this. I had a video about this like 3-4 years ago. They are very nice, but for me when I get older now the screen is a little bit small, just like the Shoji. I also have a video of this one. You have the 702, the 793. And later I also found one from the brand Fluke, and that is the Fluke 123. So after my 123, it would be a logical choice to go again for Fluke. So I have here a 192. This one is broken, and that is a bit of a problem when you look for Fluke second hand. They are or close to new, very expensive, and when they are below 200 euros they are probably broken. These models, this is the 192, so I would think the 190 series, they have a problem with the ASICs. I think it is with static electricity, or you did something wrong and you blow up, and that is the most expensive part from this whole multimeter. So this one is nice. I had a really good deal on it, but it is just a very big multimeter because the oscilloscope doesn't work. So I wanted to look for something more reliable, at least second hand is more trustable. So I started to look at the brand Siglent, and it might not be a surprise that I'm a bit of a fan of it because I have a multimeter, oscilloscope, spectrum analyzer, signal generators, and they make nice products for a good price. But weird enough, second hand, you don't find these too much. About the oscilloscopes, you can still find people upgrade, sell them. This people keep apparently, but I was lucky. I found one, so I sold my 123 from Fluke and I bought this one. Because they are in automotive, when you find them second hand, they are probably very dirty with oil, just like my Siglent. We have a closer look at that one. Here it is close by. The charger doesn't seem original, but it seems to do the job. It has been used, I think, in a car garage. We can see a lot of oil that is on the plastic, but I tried already. I have some stuff that is really toxic, so I need to use gloves. I don't think it is still available in the Netherlands, but I was able to order again still, and that is this defluxer maintenance cleaner. It is great for cleaning these types of plastic, because here it almost looks like new. Well, the rest of the meter looks like this, so I will try that. So what I'm going to do, of course, clean up, do some tests. I want to upgrade the firmware when the device is older, and this one is older. You cannot skip certain firmware versions, so you cannot just install the oldest. You actually need to read from the website what is the order you need to do, and maybe you need to do some extra things. So we're gonna read into that. I'm also gonna show that on the screen how I do that, and then we're gonna do some testing. I never realized this before until I'm just making this video, making my story with the Win92. They actually look pretty similar. Let's do some basic testing, switching it on. I'm meanwhile charging the adapter. It is the 806, 60 MHz, 1 gigasamples per second. Not bad, nice for a portable. And the screen is quite big. I have here, for instance, the O1. That is also oscilloscope with multimeter option, just like this one, but we can see it is a lot larger. It starts up in oscilloscope mode, but it also has the multimeter mode, and it even has the trend plot in that mode, so you can actually see what is going on there. Let's have a quick look at the information of the oscilloscope. User system status. We see here 39 times it has been switched on. I think I got it even in 28. This is the hardware version, we can't change that. But the software version right here, the version 3, I know we are already in version 5, so but I think you need to do a few steps in between. You cannot just jump to the latest, because the operating system is slightly changed, so you need to do and the firmware and a certain config file. We can do that first, by the way. Now let me first just do a few tests to see if it even works. Let me just get 10 megahertz from my distribution amplifier. That is a very good fit. Auto mode. Puff, there it is, quite fast. Voltage is good. I want to do the timing. Here we go. Bloop, bloop. Oh, quite fast. 10 megahertz. It is indeed. Can we do some measurement functions? Yes, let's do the rise time, and the rise time 29 nanoseconds. Okay, now we have some readout in the bottom that we can switch on and off. It says around the rise time is now 26 nanoseconds, but I don't think it can really see that like this, so let me just seems to work. Second channel. Can also do an auto setup. It's quite fast auto setup, faster than some of the desktop oscilloscopes. Okay, and you can switch the channel completely off as well, and then we have one channel, and then we have the full bandwidth on this channel. Auto. There we are. That works quite good. Let's do a quick maximum rise time test. I have here my Leo Bodnar fast pulser. Put it into a 50 ohm terminator, and let's see if we can see that. Yes, we can. Let me zoom in a bit. Measurements. That's the maximum, and it says 2.6, 2.7 nanoseconds for the maximum rise time. The fast pulse can do really in the picoseconds, so this is really the limit of the oscilloscope. So let's see the specs. Okay, that's pretty cool. According to the specifications, the 60 megahertz model, that is this one, should have a rise time of 5.8 nanoseconds and 3.5 for the 100 megahertz and 2.3 for the 150, and we are here at 2.56, 2.8, so that is good enough. It is above the, between the 60 and the 100 megahertz. So let's do some quick multimeter testing. Let me switch to multimeter mode. It is in DC voltage. We can then DC voltage, AC voltage, resistor, diode, continuity, capacitor, DC current, AC current. Okay, now we can test most of it with my LBO2. Let me connect that. By the way, it is a good fit with the terminals. That's also nice. And we are now in milliamps. Let me go to voltage. 100 millivolts. Ooh, the sample is not that fast and it needs some time to stabilize. But 100 is good. And we see here there is also a nice bar, but it seems to have the same speed. And it's both not that fast. So the sample is not crazy fast. It really needs some time to stabilize. bloop, 6000 counts. So if I go to 5, poof, full scale. One more. And then it switches over, so 6000 counts indeed. That seems to work. Let's do DC current. I go to this one, 4 milliamps. It is now, oh, that's weird. I'm into the milliamp setting here. And now instead of 4 milliamps, it thinks it's 5, and it has to do with this. You see that more often with some of the multimeters. Yeah, and now it's correct. With these models, then when you select here the full amps, you need to go to this connector, and when you then start using the other connector, it gives you total weird stuff. But they have a picture here what you should do. So, but yeah, with this setting it doesn't give you alarm because this is correct. Go to 10. But when I leave my connector here and I go to this, it will give you nonsense. It would say this is 1.245 amps and I'm still 10 milliamps. But when I do like this, as the picture suggests, then it is okay. Resistance. Well, we have a picture where you should put your connectors. This should 20 ohms. This is emulated. Yep. 100. That seems to work fine too. What else we had? We had diet mode. It is, the multimeter is not that fast. Continuity. Oof, this isn't, it takes a second. Caps. Let's get the DMM check plus. I can put it in DC, power it on already, it can heat up a little bit. I have here caps. Can we detect anything? This should be a nanofarad. Then and I didn't put a relative, so we have a slight difference. But we have 0. That's good. Let's try 1 micro. Try not to touch it. 1 micro. I think that's even correct if you look at the spec sheet of the DMM Check Plus. I didn't do any AC yet, so let me, AC current, we are here anyway. AC current. Get it in. It should be 1 milliamp, but then we need to switch over. And oh, 1.86 milliamps. That means it is not true RMS. It doesn't do true RMS. No. Then I wonder also with the voltage. Then it probably says 5.5 instead of 5. Back to yeah, 5.5. So it is not a true RMS meter. So I downloaded the latest firmware. That is the 5917. That has only the ADS file, and I have here the revision of the firmware. But they say if you have an earlier version, you first need to go to the version 5. I also have that one. That is this one. So this one we need to do first, and here it also said after, when you do this 5 version, that is the ADF file, and insert the config file. We need to do the config later. So I need this file and this file on my memory stick, and a zip. You need the ADS user. You choose the update, then you need to reboot, and then you go save recall, and you need to read the config file. Okay, let's try that. I wanted to connect it to the PC, and it just said in the PC it is the SHS800, and it didn't detect the driver. So I looked for a driver, it was not there. I installed Oscilloscope X, and it still didn't detect it. But then I switched it here from printer to PC, and then back to printer, and then back to PC, and then it suddenly it says USB TMC, and this is what we need to connect with the VISA to the any connectors. So this good. So you need to switch this a few times to get this right. And wow, what a little cleaning can do for the look of a device. Even the display is shiny again. This is all very nice. I found also screws for the battery, because those screws were gone. I was able to fit exactly. So in that sense, close to new, and it has been used only 28 times, and after the cleanup that shows. And after some EEV block magic, thanks to TV84, we even have a different startup. And look at this, I was even able to clean this. This is almost like new. I was able to glue the logo back on. And it's actually very nice because it has many compartments. Here you can add some probes or your charger. Here you can put your manual or some more cables in the front. The oscilloscope goes in here, so it's extra double protected also. Like this. The charger was not original, but does the job. You put your probes in, and that's it, perfectly protected. And also because of this handle, you have some extra protection even on the bottom of the casing here, because even though it is padded, of course, this is also extra protection. Here is double because this and because of this, so they well thought about how to build this one. So that's it, the SHS800 series from Siglent. After so many years, very good. Yes, it hurts a little bit. I sold my Fluke 123, but I got something back that is also very nice. The screen is a lot better. I like also the trend in the multimeter. I'm quite happy. Thank you for watching, and I hope to see you next time.